Robotics finals at the business plan competition. Please help me welcome Gecko Robotics from Carnegie Mellon University.
Good afternoon. This is a traditional power plant boiler. 60% of our energy comes from boilers just like this. Inside of that boiler is scaffolding. Humans need that scaffolding to do inspections. This is a big problem. Actually, $15 billion every single year is spent in this industry doing manual inspections. Hi, I'm Troy, co-founder of Gecko Robotics, and this is my partner, Alvin. We build and use robots for industrial inspections, starting with power plant boilers. This is a big problem today. Not only is it very costly, but it's also very time intensive. It takes 6 to 12 people 7 days to do a boiler inspection. Not to mention, this is such a large surface area that they only capture about 10% of the data that they need to make accurate decisions. In addition, every customer that we've talked to knows either an employee or a contractor that has died in their power plant. This is a big problem. We are solving this through wall climbing robots. That is our robot at the top of a boiler at a customer this year. We are also helping plants become more energy efficient. As time goes on, their boilers don't improve or don't continue to operate like they once did. We are identifying these problems before they occur. Things like tube leaks and heat transfer issues. Our data is so rich that we're able to help power plants achieve their thermal efficiency metrics and increase them by 4%. That is a 10% reduction in emissions. Overall, this represents 3% of the emissions that's emitted every single year in the United States alone. We are faster, cheaper, and safer option. Not only are we able to provide the best boiler inspection through our data and acquisition of that information, we are saving plants $3.4 million every single year. In addition, we are helping plants become 4% more efficient and reducing the number of deaths. 40 people died last year in this industry alone. How does the $3.4 million break down? Well, in order to do an inspection in the manual way, you have to put up scaffolding. That's what we were looking at before. That costs $200,000 to scaffold a boiler every single time. In addition, there's the inspection cost of $100,000. Not to mention, because it takes a week to do a boiler inspection, they lose out on $250,000 in revenue every single day. Every year, power plants lose about $4 million because of this. We are taking that from a $4 million problem down to a $600,000.
So, in March 2016, we have actually been building our third generation robot right here. So that is actually our demo robot, and please come to our showcase afterwards to check it out. So what does it have though? So our robot is actually focused on 3 criteria: access, sensing capability, and data analytics. Our robot uses a magnetic wall climbing technology that can climb up to areas that you would otherwise not be able to get. Our robot can climb up 100 feet high into a boulder wall. Our sensing capability involves using existing ultrasonic technology and visual system that we then integrated into an autonomous solution. Finally, we provide our unique software stack that actually does real-time feedback control and problem identification. We believe that by combining conventional technology into this innovative platform, we actually have a very good value proposition in terms of IP protection. And that's why we are currently talking with our attorney right now to make sure that all our intellectual property is actually protected. So here's actually a close-up of our robot in action. Pretty cool?
Yeah.
I hope. So what did the plant owners get though? We actually provide the exact same report that plant owners have been getting for this sampling sections for the past 40 years. Okay, we want them to be comfortable with what we provide and want them to use what they are used to. In addition, we actually provide software that have real-time problem detection that actually highlights the problem areas that you see here. So how do we approach our business? Power plants spend 9% of their budget on inspection and maintenance every single year. We approach this sales channel through trade shows, conferences, and utilizing our established networks that we've built over the past few years. We are not a product company. We are a service company that, as a service contractor, we go into these power plants and do the service directly. As such, we're actually able to generate $30,000 to $100,000 in revenue every single time we go. So how big is this? Well, the U.S. power plant spends $15 billion just on inspections and repairs alone. We are currently looking at adding additional modules that allow us to reach that market by adding in cleaning and repairing functionalities. But right now, the directly addressable market is a $1 billion U.S. power plant inspection market. But not only that, though, we want to start out in a niche place. So we're actually targeting $54 million that's being spent by 180 biomass and coal plants every single year. We believe that this is actually a good entry point, just because there are currently EPA regulations that require existing power plants to be more efficient than ever. It's a really good competitive area, and it's a much lower barrier of entry. Plus, most importantly, we already have the contacts that can get us in. But that's not really all. We really see our technology to be addressable in different markets as well. We see it adaptable and transferable in markets such as petrochemical. For example, we actually have contacts already with petrochemical plants owners that want us in to inspect their cogeneration plants as well as their existing tubes and pipes. We also have contacts in the oil and gas business looking at how we can use our technology to inspect their storage tanks, trucks, and vessels. Finally, we actually see ourselves in the space industry as well. I mean, NASA, SpaceX, and Blue Origin, they've been using the reusable rockets technology as a future in space transportation. And we believe that our technology can be easily addressed and make sure that their fuel slots can be used over and over again. So let's go back to the oil industry. Right now, there are no existing companies that use robotic technology in this specific market. The three largest competitors all have manual labor services that are extremely costly and ineffective. We believe that, in addition, we've been spending 3 years on this research and development. And we believe that, we've been spending 3 years on research and development, and we believe that even though we recognize there might be a future where robotic technology competitors might come into play, by establishing a foothold in this market now, we can create a barrier of entry for the other companies. So where are we today? We've actually done 4 inspections already, and these are real paid inspections and real customers. In addition, since we finished our robot, we have actually booked 14 more customers this year alone. This actually put us in a $1 million projected revenue, and we will be cash flow positive this year. We have extremely positive feedback from our customers. Gecko Robotics is the best viable method for routine visual inspections. And due to our early successes, we've been mentioned in numerous outlets, including TechCrunch, and also industry-related magazines such as the Power magazine.
So a little bit of company history. We began doing research and development back in 2013. We actually worked with a power plant manager to use our robot that we had developed in his plant. This allowed us to really learn the environment and be able to adapt to things that we knew would come up, different obstacles. He then introduced us to many other plants, and we were able to beta test our product over 2 years in a bunch of different environments and really come to a robot that works. In 2015, we formed the company. Today, we've done 4 paid inspections. We already have 14 customers lined up this year that are scheduled with us. In 2017, we'll start to expand outside of the 180 initial market focus and start selling to all 3,600 power plants. In 2018, we'll start to address some of the other verticals and problem areas that we've identified throughout our operations today. What's really compelling about this business is the financials. Every time we do an inspection, we get a 90% gross margin. And that revenue is recurring, because once a plant manager uses a contractor, they very rarely switch. Every year, we will be able to perform $50,000 to $100,000 inspections, sometimes twice a year. This year, we're going to do $1.5 million in revenue, and by 2020, we're targeting having about a tenth of the total power plants in the market, which represents $300 million in revenue. the 90% margin broken down? Well, we're eliminating most of the labor costs. We can send our robot with one operator, send them on comfortable travel and accommodations, and we have very minimal expense with our robots because they only cost $25,000 to build. That leaves us with a hefty margin to be able to reinvest in our business and continue to identify new solutions to be developed. How do we grow? How do we get to 440 customers? Well, today we've been selling directly to power plants. We're also talking to existing contractors that do this today. They already have the customers and they're looking for more innovative solutions to help differentiate themselves. In addition, we're making our robots completely autonomous so that we can leave them at the plant and it just runs automatically while we process the information and do what we do best. All this culminates to us becoming a data-focused industrial IoT company. There is no data standard for this industry. They don't even share much knowledge between one another. Plus, there's no historical trending, root cause analysis. Insurance companies and original equipment manufacturers don't even understand how the assets are performing. As we continue to acquire more data, this is going to be the most valuable resource for our company. Here's the team. There's 6 of us, and we have 4 graduate degrees or are pursuing our graduate degrees. We have a range of experiences in engineering, robotics, automation, energy, and a variety of business experiences. In addition to this team, we are also looking to hire an industry expert that has really been part of the selling process and can even help further our sales channel and distribution. We also have an awesome set of advisors, ranging from industry experts, the president of SIBO, who manages much of the CFB boilers, to our advisors at Carnegie Mellon, both on the robotics side as well as the regulatory. We also just went through Y Combinator, and so we have them backing us as well. We are raising here $2 million today. We've already taken in 80% over the last 2 weeks. We just went through the Y Combinator program, so that really accelerated our fundraising process, and we wanted to leave some room for some contacts here in Texas into some industries that we aren't in today. Please come talk to us, and we'd love to answer any questions that you may have. Thank you.
All right, how about one down? One down here, sir.
Really interesting technology. So who invented it on your team? And tell me about, you said you're filing for patents. Is there a university involved? Do they own any IP? And what exactly are you looking to patent?
So we invented this back in 2013. I'm one of the original co-founders, and no school owns any of the IP. We actually developed this now 3 times, iterating it to make it better and just more performance in the environment. We are own the original one as well. And from an IP perspective, we are currently filing patents with our lawyer as something that, we were so focused on building the business that we sort of lost sight of. But we realized that we have a lot of proprietary systems that need to be protected, and we're taking every measure to do that. We've identified a lot of the white space as to where our technology fits in.
Any word on how does he feel about that? Other people in this space, how does he feel? Does he feel pretty good that?
Yes. We've already identified the things that should be patented. Yes.
Okay, good.
All right. How about up there and then over here?
What are the sensor types? What are y'all actually looking at? Magnetic flux, what are y'all looking at? And how fast is the Gecko solution?
So right now to start out, we're doing ultrasonic and visual inspection. So we're measuring thickness of the individual pipe or corrosions and from the outside and the inside. And we're also providing high definition video feedback for the planner, so they can actually see how their pipes are doing 100 feet high up in the air.
Okay, how fast is it?
The robot can go up to 1 feet a second, and it can definitely go faster than that. We just need to promote it.
And can it go on a flat surface like a tank, or does it need the corrugation?
So it's ferromagnetic and it can adhere any thermal.
All right, how about over here?
Yeah, could you tell us what kind of tanks you inspect, what materials, geometry is going to go around your sharp corner between the walls and the ceilings, your power plants, which
So today we are inspecting a range of pipes and tubes, both the exterior and the interior. We can climb upside down on ceilings as well, because boilers have tubes on the ceiling. Today, nuclear is not something we're addressing, but we feel that in large part, a lot of the technologies we've built is adaptable to that environment as well. And we will get that solution in the near future.
How about down here on the front?
When you talk about climbing these walls and doing it manually, what is it that these inspectors are inspecting when they do it manually? And does your instrument inspect the same things, or does your instrument inspect the things that they do manually plus something more?
So what was really big for us is we didn't want to change their mode of operation or what they were used to. So we've taken the exact same components, which is handheld UT devices and visual data. And those two data sources allow you to identify a range of problems: erosion, corrosion, thermal fatigue. And so we're integrated the exact same technologies that are being used today and have built it into an automated platform. What really the advantage is that we're able to analyze that data in real time. They today write stuff on a clipboard and then try to transition it to an Excel document. Our software processes all that information in real time, which enables them to understand, the repair and what they need to do next.
Has there been any discussion between you and the plant managers or your customer about additional data that they would like to be able to get or not currently getting?
Yeah, so I think it's just the quantity and the coverage of data. So today they only have the ability to inspect 10% of the walls because they're so massive, the surface area is so big. And so we're taking continuous measurements throughout. And we're always looking at ways to identify, how best to, solve the problem.
How about back here?
Carnegie Mellon Grade School, thank you. I wanted to ask you, how do you make this a safety standard? And is there some type of organization that regulates all the power plants that can do this?
Sure. So, outside of the Department of Energy, there's agencies such as ASMT and ASME that regulate the standards for inspectors. That's largely more on the manual processing. So how to, do metallurgical analysis, how to be safe, also OSHA requirements. All these requirements are pushing our solution as being that much more favorable because you don't need people in dangerous confined spaces. Only one person remains on the floor of the boiler, and we have fall protection. So there's no really instance where one of our workers could get injured. Yeah, this is so prevalent today.
How about over here, Michael? On the right side.
Can we go back to the IP question real quick? I think you mentioned that this technology has been developed over a year ago. Is that right? You started developing the technology a couple of years ago, and that you haven't filed any patents yet. How are you thinking through the issues that come up with disclosures of IP, testing, working with customers in terms of preserving your rights to patent in the future?
Yeah, so publicly was discoverable in October. That's when we launched it as a formalized product that could be sold. And since we own the robot, no one else has the ability to, up until this point, be able to understand all the inner workings of how it is. And so now we're taking the proper precautions to make sure that we have the things we need to have patented, which is largely around the integration of all these components into an automated solution.
And when is the date for when you get on file?
So we are filing our provisional patent at the end of this month. So we've done a lot of the paperwork.
And over on this side.
So, first part of the question is, what sensors are actually on that thing now that you've demonstrated? And second is, how exactly does the packages, the delivery package, compete with drones over time?
Sure. So what's really important about our robot is we have contact with the wall. So drones can't do ultrasonic inspections. Today, the UT sensors are arranged in this right here. They're not here today because they're actually at an inspection right now. We don't have enough money to buy new ones. So, but now we will. And that's great. That's a great problem. But yeah, so this is our demo bot. But each of the UT sensors is arranged in this buddy mechanism. And then it has 8 sensors going all at once.
So it's just UT.
It's UT and visual as well. So HD camera. Yes.
Yeah, Derek, question.
So you first used this out in the real world about 6 months ago.
And you're getting ready at the end of this month, 6 months later, that's to file a provisional patent?
That's correct.
Okay. And what are the barriers to entry once this robot gets out there, other people can see how it works, for somebody else to sort of reinvent the wheel or compete with you? What do you see those barriers to entry?
The importance is developing the robot in the environment. So there's a lot of obstacles. There's things that are attached to the wall, there's weld caps, there's different specifications of every boiler. And so we've made our platform very adaptable to be able to address all of those. It took us 3 years. This is the 3rd generation robot. The first 2, were significantly less capable in adapting to all the different environments that we see. And so it's a challenge. I'm sure others will try to do it. But there's a lot of markets out there that aren't, being automated today, and we have a 3-year head start.
So let's get the mic on this side.
Yeah,
Oh,
yeah.
thank you. So, saw it climbing a nice flat surface, that's great. Curved surfaces inside a pipeline, in some cases inside of boilers are curved. What kind of other form factors can you work with from an inspection standpoint? And I'll reiterate, what other inspections can you do? For example, weld inspection, integrity, those types of things.
Yeah, so we can accommodate up to a 20-degree angle change. That's on the vertical platform. Horizontally, we have a lot more mobility.
Okay.
As far as what we inspect, we actually have jobs. So when we do a boiler inspection, one of our customers asked to do one of their circulating water tunnels and the critical steam pipes as well that transport between. So not only are we doing boilers, but there's application in a lot of other infrastructure.
Thank you.
You just mentioned that you're doing business now, but you haven't applied for your patent.
That's correct.
I think there could be a problem with that.
We have a year. We have a year.
You have a year?
Yes.
Why they gotta get it
So
done?
the clock is ticking, but we're only 5 months.
Okay.
Yeah, one more over here.
As a brief follow-up to that question, how important is the international market?
So the international is a large market as well. Asia has a magnitude of 10x the number of power plants that we do here in the U.S. We might be limited from a global patent standpoint, but we still have, a lot of competitive advantages in just our understanding of the environment and our connections.
Are there ongoing improvements that you hope to patent?
Yes.
Yeah, Tim?
I'm curious why you've chosen to go ahead as a service business, from what I understand, instead of as a product manufacturer. And what were the trade-offs you looked at as you decided that was optimal?
We find it doesn't change their mode of operation. They're used to outsourcing this type of work today, and they want someone to just fit that need. And so selling a robot, you wouldn't be able to get the margins either. This is recurring revenue for us, and we're able to do a lot more with the data that we're providing them.
But the question extends to, would you be selling the robot to the current providers and using them as the business opportunity, not necessarily to the end user?
Repeat the question, please.
Yeah, so his question is, would we sell it to other contractors today? And the answer is, we're partnering with them, so we're doing a revenue sharing model. We feel that that's the best method of growth for our company.
The question here, how long is the setup time when a technician arrives at the facility? Is there a couple of hours, or do you need schemas, design schemas? And once it's done, does it become an asset so you can go repeat the job at the same facility with that setup time?
Right. So right now, as soon as all is cool after it's shut down, we can go in and set up a robot within 30 minutes. And this is a huge contrast to the existing method where you spend 2 days setting up scaffold, doing inspection over 3 days, and spend 2 more days taking it down. So we are actually doing this a 7th of the speed that they're doing it.
All right. One last question?
Right.
Yep.
On your data gathering, would you be able to move towards a big data model to move forward predictive, subjective, so that you can say, say, a month from now, you say, well, it's going to be more data.
Yeah. Okay.
So the question was big data, how are you going to use the data? So there's a couple ways. Directly for the power plants, identifying historical trends, root cause analysis, as well as the optimal repair techniques. In addition, this data is also very valuable to original equipment manufacturers and insurance companies that, this is, their assets or they're insuring these assets. And so there is a network effect in having a lot of different information from different, customers as well as different original equipment manufacturers to be able to identify best practices in the industry.
All right, we're out of time.